Hey, welcome to Follow Up. Let's have a look at an easy problem for fun. So this is problem 2859, sum of values and indices with key set bits. In this video, we're going to explain a solution, basically a variables, but we want to practice the process of finding set bits. So there are actually many ways to write this code. So basically, we want for each index, we count the bits of ones, right? Then we check against k. If it equals k, then we are going to accumulate the corresponding elements in the list. So with that said, let's first look at one example. So in example 1, so we have k equals 1. So we want to find those numbers, those indices with 1 bit, right? So here the length is 5. So the indices are 0 up to 4. So here 1 is 1 bit set. Then similarly 2 and 4. So in other words, if k equals 1, so we want to find the powers of 2's, right? So 0, 2, and 4. So that's basically the problem digest, right? So once you got this one, so you're going to add this thing together. So 0, the 1, that is this one, and 2 is this one, and 4 is this one. So together we get 13, right? So here the main point is how to get the bits. So let's define a function called count bits, right? So we are going to accept an integer, right? So let's assume n is greater than or equal to 0, an integer, right? So return the n bits of ones, or the set bits. So here basically let's define a variable called nCounts. That is n bits. Let's see, maybe better. It's 0. Now let's use a while loop. So while n is greater than 0, then we are going to do integer division. So basically we want to divide n by 2 and look at the quotient and the remainder, right? So if the remainder is 0, so it means this corresponding position has a 0 bit. If r equals 1, it corresponds to bit 1. So in this case, what we want to do is n bits is incremented by this r. So if r is 1, we will add increment by 1. If 0, do nothing, but it amounts to c. We increment n bits by r. But here we want to update n to be n over 2 integer division. So we can directly do here. Change this q to be n. So this n will be updated. So after we exit this while loop, so we get the n bits, right? So we can return this n bits. So this will do our job. So next we want to find the corresponding sum. So here let's initialize a result variable and then iterate, right? For I, y in enumerate nums. So basically we want to check if count bits I, so equals the given key, then we are going to increment this result using the corresponding elements. Then we just return the result. So this finished the coding for this easy problem. Now let's do a test first. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here we do this problem in a very verbose manner. So actually if you call the binary function, right? So let's see, I can print one, says print binary, let's see 12, right? Let's see 5. So 5 will be 1, 0, 1, right? So you will get 2 set bits. Let's print it out, let's see. So you get 0b, 101, right? So if you do, this is a string, then if you count from 2, so you're going to get the binary representations. Or you can do this. So in order to find the number of 1 bits, so you're going to use binary, so 5, right? So this is the string, then count for this 1, right? So I'm going to print this out, right? So you're going to get 2 for this one, right? So you get a 2. Yeah, you can just call this function, binary function directly, but here, so this is the for loop. or there's many other ways. So for example, you can use bit operations, like say give a number. Let's say we move to the right. That's 2. This let's say move to the left. Say 2. Right. This corresponding to, this one position corresponding to divided by 2. For example, let's print 4. Let's see, and move to left by 1. So you're going to get a 2, right? This is from left, just to left. So let's do this division by 2. So you get 2. So with that said, that's about it for this problem.